Hello and welcome back, everyone, and you are looking at, right now, 1 million particles, which have simulated the creation of Saturn's rings. Or as I like to call it, a higher electric bill for me, because this has been running for a long time, but the results are absolutely amazing. And I'm here to show you in full 4K. Yeah, I'm doing this one in 4K, ladies and gentlemen, so you can really see the detail. The detail! Because there's a whole lot of it, and guess what? I also was taught by you guys in the comments how to save more state, meaning that we have the entire simulation to scrub through. So let's go ahead and undo all of it and start at the very beginning, where we have two small little moons which are going to collide to form the beautiful rings. Here we are going to have the initial impact, and let's see if I can get a good angle so you can really see what's going on here. And there we go. That grazing shot there just shoots out this huge plume of material. And you can see that outer moon being absolutely torn apart. The inner moon did not make it very far. Like, not far at all. But now it's making kind of like this flat disc where the two collided. It's kind of smushing out into this very flat oval that's just continuing to grow. And now it's starting to warp around because of gravity, and we're gonna see that the force of the actual impact is gonna compete with the gravitational pull of Saturn, causing this curve to form. The faster particles are going out away from Saturn, but the slower ones are getting captured by the gravity. All right, so now we're actually getting some really cool spread on this. Look at that. Look at the particles all the way out shimmering. You can kind of see there's now kind of like, you can see where the planet, still a little bit of the planet exists. Wasn't completely obliterated right here. Part of the surface of the planet is still kind of visible here. But for the most part, it's been absolutely shredded into a million particles. And if I zoom in, you can see that, yes, every particle is simulated. There's no tricks here where it's just like using bloom and hiding a bunch of the particles. If I go like this, you can see each particle go by the camera. Look at that. Isn't that insane? Just the amount of detail. This is living in 2024, my dudes. All right, so now we're starting to see this really awesome curve shape start to develop. We can still see kind of the sphere from that initial impact, but now we're starting to see some definition to what's going to become the rings. Look at that. The cloud of debris is actually almost as large as Saturn now. It's getting there. It's getting there, but it's going to fall back in and kind of reorganize itself soon. And that's a really cool thing about these impacts. The debris field start out and it just looks chaotic and like they're all just going to go out into the middle of nowhere. But gravity is a funny thing. And it's able to get that absolute chaos and bring a little bit of order to it, which we're going to see soon. Because this is a lot of material and gravity is definitely going to be acting on it. So I'm going to go ahead and pause. I'm going to speed this up a little bit just so that we can see this formation go a little bit faster. All right. So as this goes ahead, we can see that it's going to start actually kind of tightening into a band. And we can see at the corners the most obvious effect of this. Look at that. Let's pause. Look at the kind of stringiness too. It's just, it kind of looks like molten magma being thrown through the air. Look at how the gravitational forces are causing these patterns to form. That is absolutely insane. God, that's beautiful. It almost looks like neurons, a little bit. And we have this just huge, now it's larger than Saturn, the debris field, and it is definitely the most debris towards the initial impact, as you'd expect, but these kind of tendrils of material coming out look so awesome. So let's go ahead and kind of focus in on that. when we hit play. And you can kind of see it's getting closer now because the gravity is actually condensing it down, where originally the main force of the impact caused it to spread. Now it's doing the opposite. It's coming back together. And we're seeing that it's getting bent around Saturn. Like that. Now, some of these particles are going to impact Saturn because they're not going to be able to get away from the gravitational pull. But a lot of the particles aren't going to get pulled into Saturn. Look at that. Some of them just barely escape. Oh, no, that one's totally going to hit. Oh, well, maybe not. Maybe it survives. Oh, it actually does survive. Now, you can really see, and I'm sorry that it is kind of stuttering a little bit. I promise you, I did pre-render this whole thing. Otherwise, it would be going way slower. It's just, it's loading it from disk because I cannot store this much on RAM. Throw me a super comet or whatever to help me raise money to get 128 gigabytes of RAM, I guess. Then we can do bigger simulations much faster. All right, so now we have this field, and it has this point here, this inflection point, where the gravity is actually pulling it in, and then we have it kind of bounce out, which causes this really cool spot where it's right in the center where this all collapses in before spreading back out again. That's really cool to see. And just look at how it's being curved around Saturn. And I mean, it's one thing when you look at this on like a two-dimensional game, but being able to look in 3D and actually feel the depth of it, like if I wiggle this a little bit, I'm a huge fan of wiggling simulations like this just a little bit because it gives you kind of that depth. Like, if you look at it like this, it looks cool, but then if you kind of move it around just a tiny bit, trying to help you guys feel that depth. I don't know how mean YouTube compression is going to be, but the depth of this is just absolutely insane. You can really see just the shape and the beauty of it, really. I mean, I know it's a collision, it's an explosion, but it's still beautiful, and just the math and the physics behind it. And now I went ahead and sped it up a little bit more so that we can see this form the rest of the way. So as this kind of gets thrown around Saturn, we still have the particles which are kind of lagging behind, and they're still spreading out. But the particles which are getting pulled in are now starting to form. Yeah, you know what Saturn's known for? It's known for being married. It's got that ring. Actually, it's got multiple rings. Utah moment. Anyways, we're going to go ahead and watch as these rings form. So you can really see this curving around. These few little particles up front, and the closer they get to Saturn, the faster they're moving. And it looks like we are actually getting some of the particles slamming into the surface. Not all of the particles are going to survive this. It's so sad. Can we get an F in the comments for the non-survivors? Just look at that. We got this huge cloud of dust which is being pulled in to a ring, and just, oh, it looks so good. It looks so crazy good, and we're only halfway through. Well, I told you guys I was going to do a long simulation with a lot of visual eye candy, so I hope you're all satisfied. This is probably the coolest simulation that we can do, and well, there's more. But this is probably, I think, just visually one of the most stunning, because it's something very familiar. Everyone knows about Saturn, and most people have Saturn as their favorite planet. But this, actually seeing the rings form with a million particles, is just kind of jaw-dropping. And now we can actually see the ring is starting to form a full circle. We've got these particles which are orbiting. Now, the orbit of these particles is not stable yet. It would take a lot longer for it to kind of everything to balance out. So you can notice it's actually going to kind of intersect and cross over itself, which is going to create some kind of cool shapes. And gravity is still working. Gravity is still working between the particles and kind of pulling the rings in and together, but it takes quite a while. Saturn has had a very, very long time to make the beautiful rings it has now, and my computer will not survive long enough to get to that point. But look at what we do have. Look at that. Absolutely stunning. And I think my computer is doing a little bit better because I think this later stuff is stored in my RAM more so than my hard drive, so it's going a little bit faster loading it up. Wow. Just look at that. Let me do a little bit of a zoom on the action. Now, if I pause and scrub back through what I've loaded, you can actually see a smoother version of it. So that going back and then back forward again. Just look at that formation. Very awesome. Then we go ahead and hit play again, and I mean, first off, Saturn's ring is literally piercing through my skull, so that's cool. What's that? Can I... There we go. Cut my head off. There we go. Very nice. But, just, it's just so cool. Look at it go. Hopefully this isn't too slow for you guys. You did ask for a slower and more visual video, so. Now we're coming towards the end of this, but now we can actually see a second ring forming. The first ring has kind of gone out a little bit further with its velocity. It's starting to get a little bit more stable, but you'll notice that it's in a very oblong orbit. It is not circular. So the material moves quickest when it's closest to the planet, so it's actually moving a little bit slower out here. And this is where I stopped because hours and hours and hours had passed. I think this is a really cool point. We can already see the multiple rings forming, and eventually over time it gets more and more smaller and smaller rings. But we can also see this beautiful trail behind. This beautiful, beautiful trail behind. And making a thumbnail for this video is going to be really easy because there's just so... Like, this is so easy. Hell, I'm just gonna take the screenshot right here. Let me duck out of the way. There we go. Snipping tool. Snipping tool this. It's free real estate. Free real estate. Very nice. Wait, where did it put my screenshot? Did it... Probably just into my clipboard. Hopefully I don't lose it. Anyways, this is Saturn's rings forming, and I hope you really enjoyed this simulation. If you want to see more stuff like this, you should go ahead and subscribe. Join Valor so you can give me suggestions, and I'm just trying to go inside of the rings. Oh, that's crazy. That's crazy, the view inside of the rings. I'm just diving into Saturn's rings real quick. Average YouTuber things. Yeah, like that's insane. It's really insane that we can simulate things like this on like consumer hardware nowadays. Do the little wiggle so you can really get a feel for it. But guys, thank you for watching. Leave a like and subscribe. Let me know if you want to see anything next time, and I'll see you all then, and I'll just keep playing around with this software. SpaceSim, made by one of the guys who works on Universe Sandbox. Like, what can I say? They always make great stuff, so I'm not shocked. And if you want to know how fast this simulation actually rendered, let's go ahead and hit the play button. This is the rendering speed. So if you notice, this takes a while. So keep that in mind before you ask me to do a 28 million year time lapse, because I may have to get a second computer to render it out. But anyways, thank you for watching. Leave a like and subscribe if you enjoyed, and I'll see you all next time. Peace out.